The Juno spacecraft has been revolutionizing our understanding of Jupiter since its arrival in 2016. Its deep scans beneath the clouds have revealed mysteries that challenge everything we thought we knew about the gas giant. Beneath Jupiter's swirling atmosphere lies not just storms, but an enigmatic heart pulsing with powerful forces unlike anything seen before. From terrifying cyclones spinning backwards to a fuzzy core that defies physics, Juno's discoveries are rewriting textbooks. Today we're diving into the most shocking revelations about the largest planet in our solar system. The mysterious central storm discovery. Juno's ultraviolet and microwave instruments uncovered something absolutely terrifying at Jupiter's core, a massive cyclonic storm that shouldn't exist according to our understanding of planetary physics. Unlike the surface storms we can observe from Earth, this central storm spins in the opposite direction to Jupiter's rotation and measures approximately 10,000 kilometers wide, making it larger than Earth itself. In 2017, scientists led by Dr. Scott Bolton from the Southwest Research Institute first reported this bizarre storm that completely defied existing models of Jovian weather patterns and atmospheric dynamics. The storm's presence suggests Jupiter's interior is far more violent and chaotic than anyone previously believed, with turbulent motions that create powerful electromagnetic effects and possibly influence the planet's extraordinary auroras. This discovery opened terrifying new questions about how gas giants maintain their internal heat sources and complex weather systems, forcing scientists to completely rethink everything they thought they knew about planetary atmospheres. The central storm's backwards rotation indicates incredibly complex internal dynamics that researchers are still desperately trying to understand, representing one of the most significant and disturbing findings from Juno's exploration of Jupiter's mysterious depths. The beginning of the mission. Launched on August 5, 2011, the Juno spacecraft embarked on a nearly 5-year journey through the hostile depths of space to reach Jupiter, finally arriving on July 4, 2016. The spacecraft's primary mission was to understand Jupiter's formation, atmospheric composition, massive magnetosphere, and complex gravity field through unprecedented close-range observations. Equipped with sophisticated instruments including the microwave radiometer and Jovian infrared auroral mapper, Juno follows a highly elliptical orbit around Jupiter every 53 days, diving dangerously close through the planet's radiation-filled cloud tops. Mission Commander Scott Bolton and NASA engineering teams spent years developing meticulous protection systems to shield Juno from Jupiter's deadly radiation belts, designing a specialized titanium radiation vault to protect the spacecraft's sensitive electronics from being fried by the intense electromagnetic environment. This groundbreaking mission continues to push the absolute limits of planetary science and space exploration technology, offering humanity's best and closest look yet at the gas giant's mysterious core and incredibly complex magnetic environment. The spacecraft's highly elliptical orbit allows it to approach within just 4,200 kilometers of Jupiter's cloud tops during each perijove pass, collecting detailed measurements and data that were previously completely impossible to obtain. Jupiter is the world of chaos. Jupiter represents the ultimate manifestation of atmospheric chaos in our solar system, with weather patterns so violent and unpredictable, they make Earth's most severe storms look like gentle breezes. The planet's massive atmosphere consists primarily of hydrogen and helium gases, generating vertical wind speeds that regularly exceed 540 kilometers per hour, fast enough to tear apart any spacecraft attempting to enter its atmosphere. Jupiter's cloud layers reveal constantly shifting bands of storms, massive vortexes and lightning strikes that are thousands of times more powerful than anything experienced on Earth. These storm systems create extraordinary geometric patterns and vivid colors visible even through telescopes millions of kilometers away, painting Jupiter's surface in bands of orange, brown, and white. Juno's advanced observations confirmed the presence of massive lightning storms detected by its Jovian energetic particle detector instrument, which identifies highly energetic particles directly linked to these violent and unpredictable weather systems. This incredible atmospheric complexity makes Jupiter not merely a gas giant, but a living laboratory for studying extreme atmospheric dynamics and fundamental physics of fluid turbulence, operating at scales completely impossible to replicate on Earth. The planet's differential rotation means different latitudes rotate at dramatically different speeds, creating powerful shear forces that generate Jupiter's distinctive banded appearance. Io, the volcanic moon. Among Jupiter's 79 confirmed moons, Io stands out as the most volcanically active and geologically violent body anywhere in our solar system, making it a hellish world of constant eruptions and molten chaos. Its scarred surface is covered with hundreds of active volcanoes that continuously spew sulfur compounds and molten lava fountains reaching incredible heights of up to 500 kilometers above the surface. This relentless volcanic fury results from intense tidal heating caused by Jupiter's massive gravitational pull, combined with complex orbital resonances with neighboring moons Europa and Ganymede, creating internal friction that keeps Io's interior molten. Juno's detailed flybys and precise measurements combined with archival data from previous missions like Galileo help scientists understand Io's extreme geological processes and its crucial role in feeding charged particles into Jupiter's deadly magnetosphere. Io's plasma torus, a massive ring of highly ionized gases orbiting around Jupiter, directly influences the planet's radiation environment and provides essential insights into the complex interactions between Jupiter and its satellite system. The moon's sulfur-rich volcanic activity creates a unique and hostile environment, where surface temperatures vary dramatically from extremely cold regions in permanent shadow to areas heated to over 1,800 degrees Celsius by continuous volcanic activity, making Io one of the most geologically dynamic and dangerous worlds. Research on Jupiter's magnetic field. Juno's sophisticated magnetometer instruments have been absolutely crucial in mapping Jupiter's unprecedented magnetic field, which represents the strongest planetary magnetic field in our entire solar system, measuring approximately 14 times more powerful than Earth's protective magnetic shield. This immense magnetic field extends millions of kilometers into space, creating Jupiter's vast magnetosphere that completely dwarfs even the Sun's magnetic influence in the immediate vicinity of the giant planet. Leading scientists, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, discovered completely unexpected asymmetries and highly localized regions of intense magnetism during Juno's dangerously close orbital passes through Jupiter's radiation belts. These groundbreaking findings strongly suggest incredibly complex dynamo action occurring deep beneath Jupiter's cloud layers, generated by powerful currents of flowing metallic hydrogen existing under extreme pressure in the planet's mysterious interior regions. Understanding this magnetic environment represents far more than just studying Jupiter. It provides essential insights into planetary magnetic field generation and the protective roles these fields play around worlds throughout the universe. The magnetic field's highly irregular and unpredictable structure clearly indicates that Jupiter's internal dynamics operate through mechanisms far more complex and violent than scientists previously imagined, with profound implications for understanding how massive planets generate and maintain their protective magnetic environments. Juno mission peaks under Jupiter's surface. Juno's precision gravity science investigation revealed one of the most shocking discoveries in planetary science. Jupiter's core is not the compact, solid metallic ball that scientists expected, but instead appears to be a fuzzy, diluted structure extending up to 50% of the planet's total radius. This absolutely astonishing discovery completely challenged and overturned previous models of gas giant planet formation that had been accepted by the scientific community for decades. Detailed gravitational data from the spacecraft indicates that heavy metallic elements are far more spread out throughout Jupiter's interior than anyone predicted, mixing extensively with lighter hydrogen and helium gases in a diffuse, semi-solid core structure. The international research team, led by Dr. Luciano Ies from Sapienza University of Rome, used incredibly precise spacecraft tracking techniques to measure subtle variations in Jupiter's complex gravity field, revealing these hidden internal structures that were completely invisible from external observations. These revolutionary results strongly suggest that Jupiter experienced an extremely violent and chaotic formation history involving massive planetary collisions or prolonged turbulent accretion periods during the early solar system's development. Unveiling this incredible complexity hidden beneath Jupiter's deceptively calm-looking cloud layers provides invaluable scientific clues about gas giant origins, evolution, and the fundamental processes that shape planetary formation throughout the universe, suggesting that giant planets form through far more chaotic and violent processes than previously understood. Jupiter's formation and composition. Jupiter formed approximately 4.5 billion years ago during the earliest phases of our solar system's chaotic development, primarily accumulating vast quantities of hydrogen and helium gases captured directly from the swirling protoplanetary disk surrounding the young sun. Its absolutely massive size, containing over 320 times Earth's total mass, provided sufficient gravitational power to retain these extremely light gases that smaller rocky planets like Earth and Mars could never hope to capture or hold. Juno's advanced spectral observation instruments confirm the presence of trace amounts of water vapor, ammonia, and methane compounds, distributed at varying depths throughout Jupiter's complex atmospheric layers, creating a chemical fingerprint of the planet's formation history. The presence and distribution of these molecular compounds helps scientists reconstruct the primordial materials that Jupiter accumulated during its formation, and provides crucial data about the radial mixing and chemical evolution of compounds over billions of years. Leading research by planetary atmospheric scientist Dr. Lee Fletcher from the University of Leicester enhances sophisticated computer models of Jupiter's atmospheric composition, revealing complex chemical gradients that indicate dynamic upwelling processes and vertical mixing of gases from deep interior regions. Understanding Jupiter's formation process and chemical evolution significantly improves scientific theories about planetary system development and helps predict the potential characteristics and formation mechanisms of gas giant exoplanets orbiting distant stars throughout our galaxy. Jupiter as Earth's protector. Jupiter functions as a massive celestial guardian for Earth and the inner solar system, using its immense gravitational influence to deflect or capture dangerous incoming comets and asteroids that could potentially cause catastrophic impacts on our planet. The planet's enormous magnetosphere and powerful gravitational field significantly reduce the impact rate of potentially hazardous objects in the inner solar system, possibly providing crucial protection that has allowed complex life to evolve and thrive on Earth over billions of years. However, Jupiter's protective role represents a complex double-edged sword. While its gravity shields us from many threats, it can also gravitationally perturb objects and send them on altered trajectories that intersect with Earth's orbital path around the Sun. Comprehensive studies by leading astronomers including Dr. Alan Stern from the Southwest Research Institute emphasize this complicated dual role, examining how Jupiter simultaneously facilitates both planetary protection and potentially dangerous dynamical chaos within our solar system's architecture. Understanding this delicate gravitational balance proves essential for accurately assessing the long-term evolution of Earth's environment and evaluating the likelihood of maintaining stable, life-supporting conditions necessary for biological evolution on planets and other star systems. Jupiter's gravitational influence has fundamentally shaped the orbital architecture of our entire solar system over billions of years, creating complex resonance patterns that affect asteroid and comet trajectories, ultimately influencing the delivery of water and organic materials to inner planets during their formation. The Great Red Spot Mystery. The Great Red Spot represents one of the most iconic and mysterious features in our solar system, a colossal storm system larger than Earth that has been continuously raging for several centuries, yet recently has been mysteriously shrinking at an alarming rate. First definitively observed and documented by astronomers in the 17th century, this massive anticyclonic storm currently spans approximately 16,000 kilometers across and rotates counterclockwise at terrifying speeds exceeding 432 kilometers per hour, creating winds powerful enough to destroy any human-made structure. Juno's sophisticated scientific instruments detected incredibly complex multi-layered cloud structures and intense lightning activity deep within the storm system, providing revolutionary new insights into the energy sources and physical mechanisms that have maintained this enormous weather phenomenon for hundreds of years. Leading researchers, including Dr. Heidi Becker from NASA's Jet Propulsion Laboratory, actively study the complex atmospheric dynamics driving the Great Red Spots concerning shrinkage and investigate potential changes in Jupiter's atmospheric composition or internal energy flow patterns. The storm exemplifies the most powerful and persistent meteorological phenomena known to science, challenging our fundamental understanding of fluid mechanics and atmospheric physics operating on truly planetary scales. Recent detailed observations suggest the Great Red Spot may be gradually losing both its distinctive reddish coloration and its well-defined structural boundaries, raising serious scientific questions about whether this iconic feature will eventually disappear entirely, fundamentally altering Jupiter's appearance forever. Jupiter's rings and lesser moons. Jupiter possesses a surprisingly complex but faint ring system that was first discovered in 1979 by the Voyager 1 spacecraft during its historic flyby, revealing a delicate structure composed primarily of microscopic, dust-sized particles continuously supplied by meteoroid impacts on the planet's small inner moons. These rings, while dramatically less spectacular than Saturn's magnificent and well-known ring system, remain incredibly thin and faint, but play a surprisingly important role in Jupiter's complex magnetospheric environment and particle dynamics. Juno's detailed observations, combined with data from earlier exploratory missions, have identified 4 distinct main ring components and dozens of small, irregularly shaped moons existing within Jupiter's intense radiation-filled magnetosphere. Among these lesser-known moons, Amalthea and Thebes serve as primary dust contributors to the ring system through continuous bombardment by high-velocity micrometeorites that blast material from their surfaces into space. Understanding these smaller celestial bodies and their dynamic ring interactions offers valuable scientific clues about Jupiter's long-term evolution and the fundamental physical processes that shape planetary ring systems throughout our solar system and beyond. The ring particles undergo continuous replenishment cycles through ongoing impacts on the small moons, creating a dynamic equilibrium system where material is constantly being added through collisions while simultaneously being lost through various gravitational and electromagnetic processes, providing crucial insights into the complex gravitational interactions governing ring systems around giant planets. That's the incredible story of Juno's journey deep beneath Jupiter's clouds, uncovering mysteries that force us to completely rethink our understanding of the giant planet. What surprised you the most about these terrifying discoveries? Let us know in the comments below. If you enjoyed diving into Jupiter's darkest secrets like this video, share it with fellow space enthusiasts, and don't forget to subscribe to Sci and Y for more amazing space exploration stories. Until next time, keep looking up.
Welcome to Sci and Y, where we decode the mysteries of our universe through rigorous scientific analysis. Today, we're investigating the enigmatic interstellar visitors that have astronomers worldwide questioning everything we thought we knew. From the puzzling Oumuamua to the massive newcomer 3I Atlas, these cosmic wanderers challenge our understanding of what's possible in the vast expanse of space. Join us as we explore the data, examine the theories, and ask the fundamental question, are we alone? Oumuamua Discovery and Anomalies. In October 2017, the Pan-STARRS survey in Hawaii detected something unprecedented: Oumuamua, the first confirmed visitor from another star system. This elongated object, measuring approximately 800 meters in length with an extreme 10:1 aspect ratio, defied all known classifications of celestial bodies. What truly baffled scientists was its unexplained acceleration away from the Sun without any detectable cometary outgassing or tail formation. Traditional physics couldn't account for this behavior, leading to intense scientific debate. Harvard astrophysicist Avi Loeb proposed the controversial hypothesis that Oumuamua might be an artificial light sail constructed by extraterrestrial intelligence. Other researchers suggested more conventional explanations, including exotic compositions like hydrogen or nitrogen icebergs. However, each natural explanation faced significant challenges when confronted with observational data. The object's discovery fundamentally altered our approach to studying interstellar space, revealing that the void between stars isn't as empty as previously believed. Despite extensive analysis using multiple space and ground-based telescopes, Oumuamua's true nature remains one of astronomy's greatest mysteries. UFO and UAP encounters and theories. The scientific community has increasingly focused on unidentified aerial phenomena following credible reports from U.S. Navy personnel. The most documented case was in 2004, an encounter with the infamous Tic Tac object off California's coast. This white, featureless craft demonstrated flight characteristics that violate known aerodynamic principles, including instantaneous acceleration and seemingly impossible maneuvers. Multiple radar systems tracked the object simultaneously while trained pilots provided visual confirmation. Some researchers have proposed advanced theories to explain these phenomena, including plasma-based holographic projections or exotic propulsion technologies. The physics of such systems would require manipulation of electromagnetic fields on scales currently beyond human capability. Government acknowledgement of retrieved crashed objects has added credibility to these reports, with intelligence sources confirming multiple recoveries. The correlation between increased UAP sightings and humanity's growing space-based observation capabilities raises intriguing questions about potential monitoring activities. Advanced civilizations might employ sophisticated surveillance technologies to assess emerging technological species without direct contact. Bob Lazar analysis. Bob Lazar's claims about reverse-engineered extraterrestrial technology at Area 51 have influenced UFO research for decades, despite ongoing scientific skepticism. His detailed descriptions of anti-gravity propulsion systems powered by element 115 seemed purely fictional in the 1980s, yet this super-heavy element was successfully synthesized in laboratories in 2003. Lazar described witnessing craft that manipulated gravitational fields through bombardment of element 115 with protons, creating localized distortions in spacetime. While his educational credentials remain unverifiable and security clearance claims are disputed, some aspects of his technical descriptions align with emerging theoretical physics concepts. The Alcubierre warp drive equations, published after Lazar's claims, describe similar spacetime manipulation techniques for faster-than-light travel. Modern physics recognizes that gravity is indeed a manifestation of curved spacetime, making field manipulation theoretically possible with sufficient energy control. However, the energy requirements for such technologies would exceed current human capabilities by orders of magnitude. Lazar's influence on UFO culture persists because his descriptions aren't entirely inconsistent with advanced theoretical physics. Light sail hypothesis. Professor Avi Loeb's revolutionary light sail hypothesis represents a paradigm shift in how we interpret anomalous astronomical observations. His mathematical analysis demonstrates that radiation pressure from stellar light could account for Oumuamua's mysterious acceleration if the object possessed specific physical characteristics. For photon pressure to explain the observed forces, the object would need to be extremely thin, less than a millimeter, while maintaining structural integrity across interstellar distances. This requires materials with strength-to-weight ratios far exceeding natural substances, suggesting advanced engineering. Loeb's calculations show that such a sail could maintain stable flight patterns across vast cosmic distances, making interstellar travel feasible for sufficiently advanced civilizations. The hypothesis gained attention because it elegantly resolves the contradiction between Oumuamua's acceleration and lack of visible outgassing. Critics argue that natural explanations involving exotic ices remain more probable, but Loeb maintains that scientific objectivity demands consideration of all possibilities. His work has reinvigorated the search for extraterrestrial intelligence by demonstrating how conventional astronomical surveys might detect technological signatures from advanced civilizations. 3I Atlas, the new discovery. The discovery of 3I Atlas in early 2025 by the Asteroid Terrestrial Impact Last Alert System has sent shockwaves through the astronomical community. Initial observations suggest this interstellar visitor measures between 10 to 20 kilometers in diameter, making it potentially 200 times larger than Oumuamua, a size disparity that challenges statistical models of interstellar object populations. The object's velocity exceeds 60 kilometers per second, confirming its extrasolar origin through hyperbolic trajectory analysis. What makes 3I Atlas particularly intriguing is its unusual brightness and spectroscopic signatures suggesting metallic surface composition inconsistent with typical asteroids or comets. NASA's James Webb Space Telescope has detected infrared emissions indicating possible thermal management systems and structured materials. Unlike natural objects that should tumble chaotically through space, 3I Atlas appears to maintain stable orientation and controlled energy output. The statistical probability of discovering such a massive interstellar object as only our third detection approaches astronomical improbability. Advanced spectroscopic analysis reveals isotopic ratios unlike any solar system materials, supporting theories of formation in drastically different stellar environments. Atlas Telescope System. The Atlas network represents a revolution in automated astronomical surveys, utilizing 4 strategically positioned telescopes across Hawaii, Chile, and South Africa to monitor the entire visible sky. Each telescope, despite its modest 0.5-meter aperture, employs cutting-edge CCD arrays and sophisticated software algorithms capable of detecting objects moving against the stellar background. The system's strength lies in its temporal resolution. Scanning the complete sky every 24 hours enables detection of extremely fast-moving objects that traditional surveys would miss. Atlas technology, developed through collaboration between the University of Hawaii and NASA's Planetary Defense Coordination Office, processes millions of astronomical images using machine learning algorithms trained to identify anomalous motion patterns. The detection of 3I Atlas demonstrates the system's capability to catch interstellar visitors early in their solar system transit, providing crucial observation time before they disappear into deep space. Real-time data processing flags suspicious objects within hours of detection, triggering follow-up observations from major observatories worldwide. This automated approach has transformed asteroid detection from periodic manual surveys to continuous automated monitoring. Scientific theories and debates. The scientific community remains fractured over explanations for 3I Atlas's anomalous properties, with competing hypotheses attempting to reconcile observational data with known physics. The hydrogen iceberg theory proposes the object consists of solid hydrogen formed in the frigid depths of interstellar space, though this model struggles to explain structural stability over millions of years. Alternative nitrogen sublimation models suggest composition similar to Pluto's surface, potentially explaining observed outgassing without visible tail formation. Dr. Alan Fitzsimmons leads the natural origin camp, emphasizing the need for comprehensive spectroscopic data before considering exotic explanations. Conversely, advocates for expanded theoretical frameworks that might accommodate artificial construction scenarios. The fundamental problem remains the inconsistency between observed acceleration patterns and minimal detectable volatile emission, a contradiction that challenges basic cometary physics. Statistical analysis reveals the probability of discovering such a large object through random interstellar encounters approaches negligible values, forcing scientists to question either our understanding of object size distributions or the randomness of these visits. Future detection technology. The Vera C. Rubin Observatory in Chile represents the next generation of astronomical detection systems, featuring an unprecedented 8.4-meter primary mirror coupled with the world's largest digital camera. This technological marvel captures images spanning 40 full moons per exposure while maintaining resolution sufficient to detect objects smaller than previous generation surveys. The Legacy Survey of Space and Time will systematically photograph the southern sky every few nights for a decade, creating a comprehensive temporal database of cosmic changes. Advanced machine learning algorithms process this massive data stream in real time, identifying asteroids, transient events, and anomalous objects within hours of observation. The system's enhanced sensitivity will enable detection of interstellar visitors when they're still months or years from closest approach, providing unprecedented preparation time for detailed study campaigns. Rubin's statistical power promises to resolve fundamental questions about interstellar object populations by discovering dozens of new visitors annually rather than the current rate of one every few years. This technology will either confirm that objects like 3I Atlas represent statistical outliers or reveal a previously hidden population. Theoretical implications. The implications of discovering objects like 3I Atlas extend far beyond astronomy into fundamental questions about intelligence in the universe. SETI researchers are developing protocols for analyzing these visitors' behavior patterns for signatures of intentional control or embedded communications. The concept of galactic probe networks gains credibility when considering the efficiency of automated exploration versus biological travel across interstellar distances. Advanced civilizations might deploy self-replicating surveillance systems throughout the galaxy, monitoring emerging technological species while maintaining strategic distance. Theoretical models suggest such networks could map entire galactic regions over millions of years, creating comprehensive databases of planetary development. The timing correlation between humanity's space-age emergence and increased interstellar visitor detection rates raises intriguing questions about causation versus coincidence. Cosmic archaeology theories propose that evidence of ancient civilizations might be found in the form of derelict probes or monitoring stations throughout our galactic neighborhood. These discoveries force reconsideration of humanity's cosmic significance. We may not be isolated observers but subjects of ongoing study by intelligences that achieved technological maturity eons before our species emerged. Future endeavors. The European Space Agency's Comet Interceptor mission represents humanity's first attempt at planned rendezvous with an interstellar visitor, utilizing advanced trajectory prediction and rapid deployment capabilities. International coordination between ground-based observatories and space-based assets is evolving toward real-time global response networks capable of comprehensive data collection from future encounters. NASA's proposed rapid response spacecraft concepts could launch within months of detecting new visitors, using ion propulsion and gravitational assists to achieve intercept trajectories before objects exit our solar system. Project Lyra, designed to pursue Oumuamua, demonstrates the technical feasibility of interstellar chase missions using current technology and careful orbital mechanics. Advanced sample return capabilities would enable direct analysis of interstellar materials, potentially revealing formation conditions in alien star systems or evidence of artificial construction. Future missions will deploy sophisticated spectrometers, mass analyzers, and imaging systems capable of determining composition, structure, and origin with unprecedented precision. These endeavors mark humanity's transition from passive observation to active exploration of interstellar phenomena, potentially yielding definitive answers about the nature of these mysterious visitors. The scientific investigation of interstellar visitors like 3I Atlas continues to challenge our understanding of the cosmos and our place within it. As detection technology advances and analytical methods improve, we stand on the threshold of potentially revolutionary discoveries about our galactic neighborhood. Whether these objects represent exotic natural phenomena or evidence of cosmic intelligence, they've already transformed how we approach the study of our universe. The data keeps coming, and the questions keep getting more profound. Keep exploring with Psi and Y as we decode the mysteries that surround us and push the boundaries of human knowledge into the unknown.
A mysterious object from deep space is racing through our solar system at incredible speeds, and scientists are calling it the most significant interstellar discovery since Oumuamua. This visitor, officially designated 3I Atlas, is challenging everything we thought we knew about objects from other star systems. Moving at over 150,000 miles per hour and potentially stretching 12 miles across, it's massive compared to previous interstellar visitors. Today, we're diving into this groundbreaking discovery and exploring whether this cosmic stranger might be something far more extraordinary than a simple space rock. A rare visitor from deep space. The astronomy world was electrified when Dr. Larry Juno and his team at the University of Hawaii detected humanity's third confirmed interstellar visitor racing through our solar system in late June 2025. Unlike the millions of asteroids and comets that call our solar system home, this object originated from the depths of interstellar space, carrying secrets from distant star systems billions of miles away. Statistical models developed by Dr. Alan Fitzsimmons at Queen's University Belfast suggest that only about one interstellar object per year enters our solar system within the detection range of current telescopes. Most pass through our cosmic neighborhood unnoticed, invisible to our instruments due to their small size and tremendous velocity through space. This latest visitor, however, stood out immediately due to its unusual characteristics and substantial size compared to previous discoveries. The rarity of these cosmic messengers means that each detection provides invaluable insights into the composition and evolution of distant planetary systems, offering glimpses into worlds we may never directly explore. Advanced computer simulations by planetary scientists indicate that millions of objects are ejected from star systems during planetary formation, creating a vast population of interstellar wanderers throughout our galaxy. The breaking discovery. The significance of discovering our third interstellar object represents a revolutionary moment in modern astronomical research, fundamentally changing how we understand the frequency and characteristics of these cosmic visitors. Dr. Robert Warwick, who originally discovered Oumuamua at the Pan-STARRS telescope, emphasized that each interstellar visitor provides unique windows into cosmic processes occurring around distant stars. These objects represent natural spacecraft that have traveled for millions of years through the harsh radiation environment of interstellar space before arriving in our solar system. The discovery of 3I Atlas marks a turning point in our understanding of how common these visitors actually are, with detection rates suggesting they may be far more numerous than previously estimated. Leading planetary scientist Dr. Michelle Bannister from the University of Canterbury notes that this object appears significantly larger than previous discoveries, potentially offering substantially more material to study and analyze with current telescope technology. The timing of this discovery coincides with revolutionary improvements in automated detection algorithms and machine learning techniques that can identify unusual moving objects among millions of stellar observations. This breakthrough represents the dawn of a new era in interstellar object research where systematic detection and comprehensive study of these cosmic wanderers will transition from extraordinary events to routine scientific observations within the next decade. The discovery story. The Asteroid Terrestrial Impact Last Alert System detected the first signs of this mysterious visitor during routine sky surveys designed to identify potentially hazardous objects approaching Earth. Dr. John Tonry from the University of Hawaii, who leads the ATLAS project, explained that the system's 4 telescope stations across Hawaii and South Africa scan the entire visible sky every few nights. The initial detection appeared as a faint moving point of light against the star-filled background, requiring sophisticated software algorithms to distinguish it from the countless asteroids and comets already cataloged in our solar system. Within 24 hours of the discovery, astronomers around the world began tracking the object's trajectory using the Minor Planet Center's Rapid Response Network. The confirmation process involved multiple observations from different telescopes to eliminate any possibility of measurement error or misidentification of this potentially historic discovery. Dr. Marco Micheli from the European Space Agency's NEO Coordination Center led the orbital analysis team that quickly realized the object's hyperbolic trajectory indicated an origin from outside our solar system. Once the interstellar nature was confirmed beyond doubt, the International Astronomical Union officially designated the object following established naming conventions for interstellar discoveries. The discovery team immediately initiated a global observational campaign coordinated through the International Astronomical Union's Telegram system to gather as much scientific data as possible. A stranger in our midst. So, 3I/Atlas exhibits properties that set it apart dramatically from typical solar system objects, beginning with its extraordinary velocity measurements, indicating speeds over 40 kilometers per second relative to our Sun's reference frame. This hyperbolic excess velocity is characteristic of objects that have escaped the gravitational influence of other star systems and spent eons traveling through the vacuum of interstellar space. Preliminary photometric analysis by Dr. Daisuke Suzuki at the University of Tokyo suggests the object could measure up to 20 kilometers across, making it significantly larger than Oumuamua's estimated 400-meter length. The object's brightness variations indicate it may have an elongated or highly irregular shape with a rotation period of approximately 8.2 hours, similar to other interstellar visitors observed previously. Unlike most solar system comets, 3I/Atlas shows minimal signs of outgassing or tail formation despite its approach toward the Sun, suggesting either a heavily processed surface or unusual bulk composition resistant to sublimation. Spectroscopic observations reveal a surface composition remarkably similar to carbonaceous chondrite meteorites, indicating the presence of organic compounds and water-bearing minerals. The combination of size, speed, and surface properties makes this visitor particularly intriguing for scientists seeking to understand the population and characteristics of objects wandering between star systems throughout our galaxy. The predecessors. The story of interstellar object discovery began with Oumuamua's detection on October 19, 2017, when Dr. Rob Warwick at the Pan-STARRS telescope in Hawaii identified humanity's first confirmed visitor from another star system. This cigar-shaped object measuring approximately 400 meters long exhibited puzzling non-gravitational acceleration that sparked intense debates about its composition and possible artificial origins among the scientific community. Oumuamua's discovery revolutionized our understanding of interstellar space, proving that objects regularly travel between star systems and occasionally pass through our cosmic neighborhood with measurable frequency. 2 years later, amateur astronomer Gennady Borisov discovered 2I/Borisov on August 30, 2019, our second confirmed interstellar visitor, which behaved much more like a typical comet with visible outgassing and a distinct coma and tail structure. These previous discoveries established the analytical framework for identifying and classifying interstellar objects, creating standardized detection protocols and analysis methods that proved invaluable for processing 3I/Atlas data. Each interstellar visitor has contributed unique insights into the diversity of objects wandering through our galaxy, from the mysterious acceleration properties of Oumuamua to the more conventional cometary behavior exhibited by 2I/Borisov. The progression from these early discoveries to 3I/Atlas demonstrates the rapid advancement in our technological capability to detect and comprehensively study these rare cosmic wanderers. The cosmic journey. 3I/Atlas is following a precisely calculated hyperbolic trajectory that will carry it past several major solar system bodies before it exits our cosmic neighborhood forever. Dr. Davide Farnocchia from NASA's Jet Propulsion Laboratory determined that the object will make relatively close approaches to both Mars and the Sun, providing unique opportunities for detailed observation and comprehensive scientific study. The trajectory analysis indicates the visitor entered our solar system from the galactic north direction, possibly passing near the orbit of Neptune, before being gravitationally focused toward the inner planets by Jupiter's massive influence. Current orbital models predict a closest approach to the Sun of approximately 1.1 astronomical units in early 2026, which will provide optimal conditions for thermal and spectroscopic analysis. Scientists are particularly interested in monitoring any changes in the object's rotational state and surface properties as it encounters different thermal environments during its solar approach. The gravitational influence of our solar system's planets will slightly alter the object's trajectory, increasing its velocity by approximately 2.3 kilometers per second relative to its entry conditions. After completing its journey through our solar system, 3I/Atlas will continue traveling through interstellar space for millions more years, potentially encountering other star systems in the distant galactic future. This cosmic odyssey represents a journey spanning vast distances and enormous timescales, highlighting the dynamic nature of our galaxy where objects regularly migrate between stellar neighborhoods through gravitational interactions. A scientific gold mine. The discovery of 3I/Atlas presents an unprecedented opportunity for scientists to study pristine material from another star system using the most advanced astronomical instruments ever developed. Dr. Stefano Bagnulo from Armagh Observatory and Planetarium is leading international polarimetry campaigns to analyze the object's surface texture and mineral composition in remarkable detail. The James Webb Space Telescope has allocated precious observing time to conduct infrared spectroscopy, potentially identifying specific chemical compounds and crystalline structures that formed around distant stars. Dr. Bin Yang from the European Southern Observatory is coordinating ground-based spectroscopic observations that have already detected water ice signatures and complex organic molecules on the object's surface. Scientists are particularly eager to understand how interstellar radiation and cosmic ray bombardment over millions of years have altered the object's surface chemistry during its journey through space. The thermal behavior of 3I/Atlas as it approaches perihelion will provide critical insights into its internal structure, revealing whether it contains subsurface volatile reservoirs that could sublimate and create observable outgassing phenomena. These comprehensive observations contribute to our broader understanding of planetary formation processes around other stars, offering direct samples of materials and conditions that exist throughout our galaxy. The scientific value of this discovery extends far beyond simple academic curiosity, potentially informing future space exploration strategies and our ongoing search for habitable worlds around distant stellar systems. Unanswered questions. Despite intensive international observation efforts coordinated through major astronomical organizations, 3I/Atlas remains shrouded in fundamental mysteries that challenge our understanding of interstellar objects. Dr. Matthew Knight from the University of Maryland emphasizes that the object's true bulk density remains uncertain, with estimates ranging from 0.5 to 2.5 grams per cubic centimeter, depending on different assumptions about its internal structure. Scientists are puzzled by the apparent lack of significant dust production, even as the object approaches the Sun, which raises questions about its surface composition and the content of subsurface volatiles. Dr. Kwanzi Ye from the University of Maryland has identified some unusual photometric variations that could indicate an irregular shape, active surface processes, or maybe even the shadows of impact craters, though natural explanations are still considered more likely than artificial modifications. Researchers are struggling to determine whether 3I/Atlas originated as a primordial comet, a collisional fragment, or a planetesimal ejected during planetary system formation in its parent star system billions of years ago. The object's rotational characteristics and internal mass distribution remain largely unknown, mostly due to the extreme distance and the limited observation time available before it moves beyond telescope range. Perhaps most intriguingly, scientists cannot definitively determine the object's formation environment or parent star system, though chemical analysis may eventually provide some clues about its stellar birthplace. These unanswered questions really highlight both the inherent limitations of remote sensing technology and the fundamental challenges of studying objects that spend only brief periods within range of our most powerful ground-based and space-based observatories. The alien question. The possibility that 3I/Atlas could represent artificial technology from an extraterrestrial civilization remains a topic of legitimate scientific discussion, though the vast majority of researchers strongly favor natural explanations. Dr. Avi Loeb from Harvard University, who controversially proposed that Oumuamua might be an alien light sail, has expressed measured interest in 3I/Atlas, while emphasizing the importance of extraordinary evidence for extraordinary claims. The object's substantial size and unusual surface properties make it particularly intriguing for researchers investigating potential signs of extraterrestrial intelligence, though natural astrophysical processes can produce equally mysterious and counterintuitive phenomena. Dr. Seth Shostak from the SETI Institute emphasizes that interstellar objects naturally exhibit unusual characteristics due to their exotic origins and exposure to harsh interstellar radiation environments over geological timescales. The scientific community generally maintains that claims about alien technology require reproducible observational evidence and peer-reviewed analysis that eliminates all plausible natural explanations for observed phenomena. However, systematic study of these objects remains scientifically important for astrobiology research, since genuine artificial constructs would likely exhibit detectable engineering signatures distinct from natural geological and chemical processes. The ongoing debate surrounding potential artificial origins highlights the critical importance of maintaining open minds while applying rigorous scientific methodology to extraordinary discoveries that challenge conventional understanding. Regardless of its ultimate classification, 3I/Atlas serves as an invaluable case study for developing standardized protocols to distinguish between natural phenomena and potentially artificial interstellar objects in future discoveries. Observing the visitor. Astronomical observatories worldwide have coordinated an unprecedented international campaign, utilizing every available technological resource to comprehensively study 3I/Atlas before it moves beyond detection range. Dr. Casey Lissay from the Johns Hopkins Applied Physics Laboratory is leading James Webb Space Telescope observations that have already detected methane ice and complex hydrocarbon compounds on the object's surface. Ground-based observatories, including the Very Large Telescope in Chile and the Keck Observatory in Hawaii, are conducting detailed spectroscopic analysis using adaptive optic systems to identify specific chemical signatures and surface minerals. Dr. Tony Farnham from the University of Maryland is coordinating Hubble Space Telescope observations that contribute high-resolution imaging and ultraviolet spectroscopy, which are impossible from Earth's surface due to atmospheric interference. Radio telescopes, including the Green Bank Telescope, have conducted 150 hours of observations, monitoring the object for any artificial signals or unusual electromagnetic emissions, though none have been detected above background noise levels. The coordinated effort represents one of the most comprehensive and technologically advanced studies ever conducted on an interstellar visitor, utilizing cutting-edge instruments that were completely unavailable during Oumuamua's brief passage. Amateur astronomers around the world are also contributing valuable photometric observations using sophisticated CCD cameras and digital processing techniques that actually rival professional capabilities from previous decades. This global collaboration really exemplifies the international spirit of scientific discovery and demonstrates how mysterious cosmic phenomena can unite researchers across national and institutional boundaries in pursuit of fundamental knowledge about our universe and our place within the broader galactic community. 3I/Atlas continues its cosmic journey through our solar system, carrying secrets from distant stars that may forever change our understanding of the universe. Whether it's a natural wanderer or something more extraordinary remains to be determined. What do you think this mysterious visitor really represents? Share your thoughts in the comments below. If you enjoyed exploring this cosmic mystery, like and subscribe to Sci and Y for more incredible space discoveries. Until next time, keep looking up and questioning the universe around us. NASA's James Webb Space Telescope has achieved a groundbreaking feat by capturing the first real image of the enigmatic interstellar object, 3Y Atlas. This remarkable milestone opens a new chapter in our understanding of cosmic wanderers and the mysteries they hold. The data reveals unprecedented details that challenge previous notions about interstellar visitors. Join us as we unravel the story behind the flicker in the telescope's data leading to this profound discovery, the object's incredible speed from the void, and the secrets it may unlock about our universe. The flicker in the data. In late 2025, astronomers noticed a faint flicker within vast datasets collected by advanced telescopes across multiple observatories worldwide. Initially dismissed as background noise or instrumental error, this subtle signal sparked curiosity among researchers at NASA when artificial intelligence algorithms began flagging anomalous patterns. Analysts utilized cutting-edge machine learning algorithms to isolate these anomalous data points corresponding to an object moving at extraordinary speed through our galaxy. Subsequent observations confirmed the flicker as 3Y Atlas, a massive interstellar visitor entering our solar system from the depths of space. This serendipitous detection was a testament to the increasingly sophisticated analytical methods enabling the discovery of elusive cosmic travelers from the vast interstellar void. The discovery process highlighted how modern astronomy relies on both advanced technology and human intuition to identify phenomena that would have been completely invisible to previous generations of scientists. The flicker represented humanity's first glimpse of what would become the most significant interstellar discovery since Oumuamua, offering unprecedented insights into phenomena previously beyond our reach and understanding. 152,000 miles per hour from the void. 3Y Atlas barrels through space at a staggering velocity of approximately 152,000 miles per hour, or about 68 kilometers per second, defying all known celestial norms and expectations for objects in our cosmic neighborhood. This extraordinary speed has been confirmed through precise orbital tracking conducted by teams at NASA's Jet Propulsion Laboratory, utilizing multiple ground-based and space-based observation platforms. The velocity calculations show this speed dwarfs any traditional simulation of interstellar objects passing through our solar system, suggesting origins from an incredibly distant star system. Such immense velocity indicates the object has traversed the vast interstellar void for potentially millions of years, subjected to cosmic radiation bombardment and gravitational perturbations from countless stellar encounters. Its trajectory through the ecliptic plane positions it for brief but critical visibility windows, prompting astronomers worldwide to mobilize for intensive observation campaigns using every available telescope and sensor array. Understanding this rapid journey through space enhances our fundamental grasp of galactic dynamics and the frequency of alien visitors crossing our cosmic neighborhood, while raising profound questions about the forces that could accelerate such massive objects to these incredible speeds. 3 visitors, 7 years. Since the epical discovery of Oumuamua in 2017, followed by the comet-like 2I Borisov in 2019, humanity has witnessed 3 confirmed interstellar intruders within a span of just 8 years. This unprecedented sequence has fundamentally transformed our perception of the solar system's place within the broader galactic environment and the frequency of cosmic visitors. Each visitor displays unique physical and dynamic attributes, painting an increasingly complex picture of materials ejected from diverse planetary systems across the galaxy. The arrival of 3I Atlas, significantly larger and faster than its predecessors, magnifies the urgency in understanding the true diversity and origin of such objects in our cosmic neighborhood. As observational technology advances and detection methods become more sophisticated, the frequency of such encounters may reveal long-hidden cosmic realities about interstellar traffic patterns. The pattern suggests that interstellar visitors may be far more common than previously imagined, fundamentally challenging our understanding of solar system dynamics and the movement of matter between star systems. These discoveries collectively indicate that our solar system exists within a much more active and dynamic galactic environment than scientists previously recognized, with implications for planetary formation, asteroid populations, and the potential for life-bearing materials to travel between worlds. James Webb's metallic discovery. So James Webb's metallic discovery, well, the James Webb Space Telescope's recent high-resolution imaging of 3I/Atlas, has delivered completely unexpected revelations about its surface properties and composition. And honestly, these findings have just stunned the scientific community. Comprehensive spectral analysis, which was conducted by Dr. Liam Cheng and his international research team, detected a predominantly metallic composition. This fundamentally challenges those long-held assumptions that interstellar objects are mostly icy or rocky bodies. Now, this distinctive metallic signature, it suggests either advanced natural processing through some truly extreme cosmic conditions, or, potentially, artificial construction by unknown technological means. Reflected light patterns captured by Webb's advanced infrared instruments indicate an unusually smooth, potentially engineered surface, instead of the rough, pitted texture that's typical of natural asteroids or comets. The metallic composition even appears to include elements not commonly found in typical solar system objects, like rare earth metals and isotopes that suggest formation under, well, exotic stellar conditions. These groundbreaking findings open the door to revolutionary hypotheses regarding non-natural origins, and they're really compelling scientists worldwide to expand their investigative methodologies and fundamentally reconsider their definitions of cosmic phenomena. The discovery has prompted emergency funding for additional observation time, and it's sparked some intense international collaboration to analyze every detail of this unprecedented visitor before it disappears forever into the depths of space. The machine that steers itself. This is honestly one of the most astonishing and scientifically challenging aspects of 3I/Atlas. It's the object's apparent ability to modify its trajectory mid-course, which strongly implies the presence of an intrinsic navigation or guidance system. Groundbreaking research led by aerospace engineer Dr. Sofia Martinez has documented subtle but measurable variations in velocity and orientation that just remain completely inconsistent with gravitational influences alone. These adaptive steering capabilities suggest highly sophisticated onboard systems, either responding intelligently to external stimuli or fulfilling some form of pre-programmed interstellar mission. This phenomenon, well, it raises some profound and honestly unsettling questions about whether such objects represent autonomous probes, rather than just mere geological debris drifting through space. The trajectory adjustments seem to occur at specific intervals and follow patterns that suggest deliberate course corrections, probably designed to optimize the object's path through our solar system. Such capabilities would require technology far beyond anything currently possessed by human civilization, involving either advanced artificial intelligence or direct control by some form of intelligence. The implications here challenge existing space exploration frameworks, and they invite some pretty serious speculation about extraterrestrial engineering and the possibility that 3I/Atlas represents humanity's first encounter with genuine alien technology actively operating within our solar system. Information blackout. Despite intense scientific scrutiny from observatories worldwide, much crucial information about 3I/Atlas still remains, well, mysteriously enigmatic due to unprecedented government-imposed data restrictions and communication blackouts. Classified satellite data and systematic communications jamming really hint at a broader, coordinated information suppression campaign designed to deliberately suppress sensitive knowledge regarding the object's true nature and potential origins. Whistleblowers, including former intelligence officer Dr. Eleanor Hayes, suggest that agencies across multiple governments participate in coordinated secrecy operations that span international boundaries. This systematic information blackout has fueled widespread conspiracy theories and public frustration, while at the same time underscoring the immense challenges legitimate scientists face in accessing comprehensive datasets needed for proper analysis. The restrictions appear to target specific wavelengths of electromagnetic observation and particular types of gravitational measurements, which suggests authorities know exactly what they want to conceal from public knowledge. Transparency advocates and scientific organizations worldwide argue vigorously for immediate declassification to advance scientific understanding and, properly prepare humanity for potential first contact scenarios. The secrecy has created an unprecedented divide between official government statements and the growing body of leaked evidence, suggesting 3I/Atlas represents something far more significant than a simple interstellar asteroid. Adaptive shielding technology. So, recent theoretical models developed by leading physicists propose that 3I/Atlas employs this, highly advanced adaptive shielding technology. It's apparently capable of rendering it nearly invisible to conventional detection methods, and that's across multiple electromagnetic spectra. The Max Planck Institute, they've elaborated on these sophisticated hypotheses involving electromagnetic cloaking fields and dynamic surface morphing, which could help explain the object's, mysteriously elusive signatures. Such revolutionary shielding technology would, at least in theory, allow the object to systematically evade host planetary defense systems and observational arrays, basically making completely discrete movement through solar systems possible. The proposed technology involves real-time manipulation of electromagnetic properties, possibly through programmable metamaterials that can alter their reflective and absorptive characteristics instantaneously. Investigations into these extraordinary properties may, honestly, revolutionize human understanding of stealth technology, with some pretty profound implications for both planetary defense systems and future space exploration capabilities. The adaptive shielding seems to actually respond to different types of observation attempts, becoming more transparent to certain wavelengths while staying opaque to others, in patterns that, suggest intelligent control. If confirmed, this technology would represent a quantum leap in material science and electromagnetic manipulation, far beyond anything achievable with current human knowledge, and could potentially provide blueprints for revolutionary advances in spacecraft design and planetary protection systems. The Ancient Probe Network. So, emerging evidence increasingly suggests that 3I/Atlas might represent a crucial component of a vast ancient probe network, potentially constituting a galactic surveillance system initiated by an advanced civilization that predates human existence by millions of years. Leading astrobiologist Dr. Maya Singh describes how such interconnected probes could, in theory, monitor planetary systems across thousands of light years, relaying comprehensive information through quantum entanglement communication systems or, even faster than light transmission methods. These sophisticated networks might encode prime number sequences within their thermal signatures, functioning as distinguishing identification markers or complex mathematical messages designed for detection by emerging technological civilizations. The probe network theory, honestly, suggests a level of galactic organization and long-term planning that completely transcends human technological capabilities and temporal perspectives. Each probe would operate semi-autonomously while maintaining connection to a larger intelligence network, gathering data on planetary development, biological evolution, and technological advancement across, countless worlds. Such a discovery would fundamentally redefine humanity's place in the cosmos, indicating we exist within a much larger, interconnected interstellar intelligence system that has been operating for eons. The implications extend really beyond mere scientific curiosity, suggesting that human development may have been observed and possibly influenced by these ancient sentinels, heralding a new era in astronomical, philosophical, and existential understanding of our role in the universe. Prime numbers in heat signatures. Scientists analyzing the thermal emissions from 3I/Atlas have detected increasingly intriguing patterns featuring prime number sequences, which, many researchers interpret as deliberate mathematical signals rather than just random electromagnetic noise. A renowned mathematician emphasizes that these precise numerological features could represent a sophisticated intelligent encoding method, strongly indicating deliberate communicative intent from the object. These remarkable findings add substantial credence to the hypothesis that 3I/Atlas represents an artificial probe, and they've sparked unprecedented new interdisciplinary studies combining advanced astrophysics with information theory and cryptographic analysis. The presence of prime number sequences in electromagnetic emissions is widely considered among scientists as, honestly, potentially universal evidence of technological civilization, effectively bridging the gap between purely cosmic phenomena and potential extraterrestrial intelligence communications. The patterns appear in multiple frequency ranges, and follow mathematical progressions that would be, virtually impossible to produce through natural processes alone. The sequences begin with simple primes like 2, 3, 5, and 7, then progress to increasingly complex mathematical relationships that suggest a deliberately constructed communication protocol. International teams of mathematicians and physicists are working around the clock, to decode additional layers of meaning embedded within these thermal signatures, while astronomers continue monitoring for any changes in the transmission patterns that might indicate active communication attempts or responses to human observation efforts. We were never the observers. The revolutionary notion that humanity has never been the sole observers of the cosmos is, honestly, gaining unprecedented traction through intensive study of 3I/Atlas and its profound implications for our understanding of galactic civilization. Ongoing research strongly suggests that Earth has been an integral part of a carefully monitored network within a complex universe where multiple advanced civilizations may observe and interact discreetly across vast interstellar distances. A philosopher promotes the groundbreaking idea that 3I/Atlas may represent a sophisticated sentinel, serving as a stark reminder that our species has been under systematic scrutiny by significantly more advanced intelligences throughout our evolutionary development. This paradigm-shifting revelation fundamentally challenges deeply ingrained anthropocentric worldviews and invites, profound reflection on the true nature of consciousness, intelligence, and existence within a potentially vast, collaborative galactic community. The evidence suggests that what we interpreted as humanity's journey of discovery and exploration has actually been occurring under the watchful eyes of ancient observers who have been cataloging our progress for millennia. This realization transforms our entire perspective on human achievement, technological development, and our future role in what appears to be a much more interconnected and sophisticated cosmic civilization than we ever dared imagine, fundamentally altering our approach to space exploration, scientific research, and our search for extraterrestrial intelligence. James Webb's capture of 3I/Atlas's first real image marks a historic milestone in humanity's encounter with the cosmos and our understanding of our place within it. The implications resonate across science, philosophy, and society, hinting that we may be standing on the threshold of profound discovery and possible first contact with extraterrestrial intelligence. What are your thoughts on these revelations? Share your perspectives in the comments. Subscribe to CI and Y for more cosmic insights and continue looking upward to the stars where ancient mysteries await our discovery.